Any electrical circuit that you study must have certain components in order for it to operate. This lesson will deal with some of these requirements for a practical circuit. This illustration shows the action of electron flow or current between two differently charged bodies. The basic requirements for electron flow are satisfied in that there is a potential difference between the bodies and a conductor connecting them. Although this action takes place in all circuits, this type of connection is not a practical circuit. Now I'll show you why it's not a practical circuit. The negative terminal of this battery is at a different potential than this terminal. By connecting a conductor between these terminals, electrons will flow from the negative terminals of the battery to the other terminal. This equalizes their charges. But, as explained before, this is still not a practical circuit. Why not? Well, because the electron flow or current passing through the conductor does not serve any useful purpose. Now, this bell is a resistive or power dissipating device. It requires current to function properly. I'm going to connect it here. We're building a practical circuit, but we don't have one yet. What else do we need? Well, let's add this conductor between the positive terminal of the battery and this terminal. Finally, we have a simple practical circuit. I say practical because this power dissipating device is operating. Now, what three requirements for a basic practical circuit do we have? There is an EMF force, a battery. Two conductors join the EMF source to the power dissipating device, which, of course, in this case, is the bell itself. For number 1 on your response sheet, list 3 requirements of a practical circuit. Here they are: a source of EMF, conductors, and a power dissipating device. Any order is correct. With these facts in mind, do number 2 on your response sheet. Source of EMF, a resistor or power dissipating device, and a conductor. Resistors are power dissipating devices, so either term would be an acceptable response. Now, I've built a simple circuit and identified its 3 components. You saw the actual parts as I assembled the circuit. Here you see the same practical circuit represented pictorially. There is yet another way to show this circuit. This schematic shows the same circuit in still another form. Notice the difference. Symbols are used to represent the electronic units. You must be able to recognize the actual parts and relate them to their correct symbols. You've seen the battery. Here's the battery symbol. Let's tie them together and fill in number 3 on your response sheet. That's an easy one. C and B, in that order, are what you should have. You'll learn other symbols in this lesson also. The power dissipating device is a bell. Here is the symbol. Conductors, which are also circuit requirements, are shown symbolically like this. However, in more complex circuitry, conductors often cross over like this. But they're not electrically connected. The conductors, or wires, are the components. These two conductors are electrically connected. Their insulation has been removed and the wires soldered. This provides a common path for current. Now here's the schematic symbol for connecting conductors. Also, here is the one that is not connected. Now fill in the blanks in number 4 with the correct letters. The correct answers are C, A, B, and D. Only that order is acceptable. This is a good time to discuss another method of symbolizing crossed over and connected conductors. I'll explain this method because I'm sure you'll come in contact with it at one time or another. In this diagram, the upper symbol is another way of showing crossed over conductors in schematic diagrams. The loop emphasizes that the conductors are not connected. Connected conductors are indicated by the lower symbol. These two symbols are usually used together. Be careful not to confuse the two methods of showing crossed over and connected conductors. And now you know the symbols for batteries, crossed over conductors, and connected conductors. These components were all used in this simple circuit that I built. This is the circuit. I can make it more practical by adding other components. A switch and a fuse. You'll recognize a switch as a circuit controlling device or simply a means of turning the circuit or a component on or off. A fuse is a safety or protective device for the circuit in which it's located. And now we'll complete our circuit. As you can see, the circuit is completed. This is the symbol for a simple switch. It's called an SPST, or single pole, single throw switch. The symbol for a fuse is here. Think of a circuit protective device when you see this fuse symbol in a schematic. Complete number 5. Indicate by letters the component and its correct symbol. You should have matched A with D and B with C. We already have one power dissipating device in our circuit, the bell. I'm going to add another very common one, a lamp. Since a lamp has resistance, it too is a power dissipating component. Again, we'll add another switch. Now, our circuit is complete. What does the symbol look like? This is the lamp symbol. It's used in schematics to represent most standard lamps or bulbs. And as you recall, we also installed another switch within our circuit. Use the correct letters to complete number 6 on your response sheet. To be correct, you must have B and C, and in that order only. Another circuit component is ground. It can be defined as a common reference point from which voltages are measured. Probably you already have some experience with electrical ground. In a car, the chassis or frame is used as a common reference or ground. The same thing is true of aircraft. The frame is ground. In electronic equipment, we also use this method of grounding. The frame or case, or you'll probably hear chassis more often, is the common reference or ground. I'll show you this. Here is ground on this piece of equipment. How is ground shown schematically? We'll put it here in our schematic. You'll be seeing and using the ground symbol often. At this time, write the correct letters for number 7. If your answers are C and F, you understand ground and can identify its symbol. Since I'm talking about circuit components, let's consider some measuring devices that become circuit components when they are being used. Measuring devices, or meters, are used for determining values of voltage, current, and resistance. This voltmeter is used for measuring voltage. The letter E, you'll recall, is the symbol for voltage. Voltmeters are found in many sizes and shapes, but you can recognize them by the information on the face. Look for the word volt, voltmeter, or the abbreviations AC and or DC, or both. The symbol for a voltmeter is this. You'll see it in schematics instead of a picture of the meter. Now, give number 8 a try. D is correct for the symbol, and A for the picture of a voltmeter. Here's an example of an ammeter. These also are manufactured in various shapes and sizes, but some form of the word ampere will appear on the meter face. The symbol for the voltmeter and ammeter are similar. I'll add the ammeter symbol to the schematic. You can readily see the difference. V is for voltmeter and A is for ammeter. Now do project 9 on your response sheet. B and C, in that order, are the only correct answers for this one. This is an illustration of an ohm meter. When you studied resistance, you found out that the particular unit of resistance is an ohm. The word ohm, or ohms, will appear on the face of a meter that is used to measure resistance. What does the ohm meter symbol look like? It's very close to the other meter symbols, except that there is the word ohm or ohms within the circle. I'll add the symbol to our schematic. In number 10, identify by letters the ohm meter and its symbol. A is correct for the ohm meter and D for its symbol. I've shown you a voltmeter, an ammeter, and an ohm meter. These are treated as separate devices. For convenience, the functions of all three devices, the voltmeter, the ammeter, and the ohm meter, are usually combined, included in one case. This combination is called a multimeter. Here's an example. In the military, this is called the PSM-6. This meter can perform all three functions. The desired function is determined by positioning this selector knob. Notice the different scales. These scales are used when measuring voltage or current.